Hello, everybody. I hope you're enjoying the Call for Code Hackathon. My name is Martin Hickey, and I'm a developer in the Open Technology Division. And I would just like to talk to you today about APIs and the Open API specification. So when we develop software, be it applications, services, microservices, systems, etc., we're always trying to talk to other applications or other services. And how we normally do this is through the application programming interface, or the API, which is your intermediary between you and your other service. And it defines the contract or the different operations that you can use and the different objects you can operate on. The APIs are very important because it tells us what we can do. So having good APIs and clear APIs are very important, so we can understand what we can do with the other system or what other users or other systems can do with our application. They're also a very good way of encapsulating or hiding the underlying implementation. And that means then we're just worried about the contract, or interested in the contract and how we operate across that. So getting started, I would like to first of all show you a particularly non-consistent API. So you can see the API on the left-hand side. There's 3 gets, and each one is returning a monarch, be it all the monarchs, a particular monarch, or even a monarch from a particular country like Britain or Holland, etc. And also we have a delete. So you can see here, first of all, the verb get and delete. They're not really necessary. The 3 types of calls for the get could be condensed down into one call. And also you can see here there's use of single and plural nouns around the monarch. So if we look at that again, and this time we take a more consistent API approach on it. We can first of all extract the verb out of it and make that HTTP verb of get and deletes. Secondly, we've condensed the monarch, the get on the monarchs down to one API call, which is monarchs. And then when we want to get a specific monarch, we can pass on the path, the particular ID, or else we can use on a filter on the path if we want for a particular country, like the UK in this situation. And finally, then we have the delete below, which is monarchs again, and we can delete on a specific one using the path. You can see here it's more consistent, it's more easy to use, it's more condensed down, and as a consequence, then it'll be easier for your user to use, or if you're using someone's particular API. James Gosling has a nice quote here. He's the Canadian software engineer and also the creator of Java. And it hangs true that if people can read your API straight away or use it straight away, then basically they're going to run with it. Otherwise, you're resorting to them trying to find some documentation or looking behind the implementation behind it to understand what's going on. And at that stage, its usability has become muted. So here's a few practices mentioned around when you're doing RESTful web APIs. As I mentioned earlier, there's no need for the verbs. You can basically extract it out and use the HEV verbs or actions. That when we're also defining APIs, we're looking at what are the resources that can be operated on, and they're the particular actions you're going to show. I mentioned about the nouns, and also then showing responses using HTTP responses as a standard way, and also looking at JSON as the de facto. So this has helped a lot around APIs today. It's, I suppose, it built on what was learned on SOA when they were using XML, that now you have the rest built on top of the HTTP protocol, and then using JSON as the body load. Excuse me, and it provides a means for you to extract away from the underlying implementation of the particular application you're connected to, and also has helped a lot with microservices, etc., to be able to communicate from from the different services. And finally, around authentication, to follow industry standards like OAuth, etc., rather than following a standard that may become defunct. So when we're looking at designing our APIs, we saw earlier that what I talked about a few minutes ago was around the ability to be able to design it in a nice, consistent manner, be able to come up with what type of format you're going to use, and then to follow that format through. And when you're doing your APIs, to help you drive forward and work with this, it's handy to use an API specification. There's a number of specifications out there. What I'm going to talk about at the moment, what I'm going to talk in this talk, is around the Open API specification. So what is the Open API specification? To put it simply, it's just a text document which defines your APIs. As I mentioned earlier, it's using REST, so you know it's going to be HTTP verbs, the standard verbs like post, like get, like delete, etc., and that your responses are going to be in HTTP. So straight away, you know when you're reading it, you're going to have an understanding of it. If you have some knowledge of HTTP, and if you're not, it's quite easy to pick up. But what's important around it is the tooling that's provided. So this tooling can take that specification and generate documentation, etc. And I'll talk about that in a minute. The two formats that you can write the specification in are YAML or JSON. And it has been open sourced. So SmartBear, the company, open sourced it a number of years ago, working with companies like Google, IBM, and Microsoft. And this has now come under the Linux Foundation project called Open API Initiative, and you can see the link there for getting to the specification. So from a development point of view, what does this help you with? I think one of the biggest gains here is around your iteration and your rollout. So using the specification, you can generate documentation, and that documentation is rendered in a browser, depending on the tooling. And you can go straight away to the different APIs, and you've tried out capability. So what this means is straight away you can create your testing. You can do one-off testing, as I say, with the tried out capability. Or excuse me, you can also generate some client SDKs in different languages of your choice. And there's different tools written in different languages as well to do this. And what it means then is it gives the different components of your development team, for example, your test team, etc., or your testers, etc., to already start writing up some tests. And then as your APIs become implemented, then they'll be able to straight away test on it. So it does faster rollout. It gets iterative testing going much easier. And this all stems from your specification, which is both machine and human readable content. Just to mention as well, as I mentioned earlier, of course you get a structured design approach to it. So I'm just going to show an example of a specification, and in a minute I'll go to a demo to look at it a bit more. So you can see here, this is kind of a standard structure. You have what Swagger version you have at the moment. It's what I've here is 2.0, but the current specification is 3.0, the next spec up. You can see here the API, I'm saying it's version 1 of this API, and I'm using HTTP, but more than likely you use HTTPS on this. And I'm using, in my definition section, I've defined one object that we're going to do operations on. And this object is called visitor. And the object has two properties, name and ID. They're both of a type string. And the object has, name is the only required property. Also, you can see here I've added examples. And in a few minutes, I'll show that these examples using some of the tooling can be rendered out into documentation, etc., to give more specifics to the user. When we look at, I'm just showing one of the examples of the APIs. In this example, I've shown the post. As you can see, I'm using the plural noun in this situation for visitors. So you can do a post operation. There's a description, etc. You can see the parameters is it takes in the body. It takes the visitor object that we showed earlier. So let me just highlight it here. Oh. It takes the visitor object that we showed earlier, and that basically it returns its responses, HTTP responses, 201 for a success on the post. And that will, in the body of that response, you'll see it will also have the visitor object. So why that happens is when you're, sometimes when you're creating to a service, it's going to generate an internal ID, and it does in this situation a GUI or UUID, and this is returned back to you as the user for a reference afterwards when you want to reference the object, for example, maybe when you're doing a delete. And then we get a 409 on an error or a duplication error. Just a quick look overall. I mentioned about the ecosystem and the tooling that's there. So there's quite a lot out there, and it's they're written in different languages. A lot of them are open source. There are also some commercial products from SmartBear and other companies. But some of the things that are very useful are around the documentation, which I mentioned, generation documentation, also around particular implementation that you can generate the client stubs or the server stubs if you want, and also your client libraries. And they can be generated in different flavors of your choice, for example, Python, Java, etc. And this can be very helpful to people that are going to use your particular service. So, for example, if you're building on an application for the call for code, and maybe your application can be built on for disaster recovery, etc., that having the ability to generate the different SDKs is very useful to for the developers that are going to use it. Also around mocking and testing, there's a lot of capabilities there. So I think what we'll do now is we'll jump into a little demo. So right, here we go. So what I have here is, let me just go full screen here. What I have here is a very simple Node application, a little web app, where we can add visitor names, and it just does a simple cache. So it's quite a simple app, but I just want to get across the ability of open APIs, etc., and how to use it. So in here, my endpoints are defined in server.json. And you can see here, I have my first endpoint here is the visitor's post, and you can see up above it, just access this now. You can see here I have a comment, and straight away what jumps out to you if you've seen HTTP before is it's in real HTTP format. It's a post, the responses, etc., and it's written in YAML. And the thing you'll notice at the very start of the comment is it's got an annotation at API. So what this comment is, this is actually an open API specification defining this particular API. And you can see throughout the document, I have it above every endpoint, the gets, etc. So why I've put this in here is and I'll show in a minute when I run it, is there's a tool called Swagger Inline, and what it can do is once you, and I'll show the command in a minute, once you give it the file or files where you have your particular specification comments in, it can pull out those specifications and generate the open API specification from it. So you can see the value of this from a CI/CD pipeline, where your specification can always reference the particular build or version of your service that you have. Now I'm just going to come down here to the bottom, and there's just 3 lines I want to show you here that I added. So this is, as I say, is standard JSON server using Express as the application server, and what I added in here was this tool, and it's called Swagger Tools. Now, Swagger Tools is another tool written in Node as well. And what this tool does is it can render open API. It can render documentation from an open API specification. And this documentation is rendered and loaded alongside your server and with your server's URL /docs. So it's available from /docs. So I'll show that in a minute. So here, what you're doing here is I defined a variable here, and this variable points to the location where the OpenAPI specification is going to be generated. Now I know where that area is going to be because I'm going to specify the area and the name of the specification when I run the tool. So I think best thing is to jump on to generating the specification and seeing then when the documentation can be rendered from that specification. So I'm just going to bring up the command here. Okay, so you can see the command here, and the command. Just move this out of my way. So the command here, first of all, you're calling the tool name, Swagger inline. Then you're going to call the a pointer to or reference the file or files where your comments are defined in, and then you're going to say a base. Now I'm going to look at this file in a minute, but this file is where I've defined the definitions or the objects that you can operate on, because it's cleaner to pull it out into a separate file. And we'll see in a minute. This is the visitor object. Then the format. In this situation, I'm going to use JSON because some of the tools I'm using are JSON. And then finally the output directory and file. So the path to the file that's going to be generated. Okay, so I'm going to run this, and you can see here that it's found one file to match, which is a server.js, and it's generated 4 Swagger definitions, which are for our 4 APIs, our 2 gets, our delete, and our post. So, and you can see here there seems to be a bit of bug in the tool because it went Swagger.json created rather than the name of the file. So, like as I said, a lot of these tools are open API, and there can be a few nuances from time to time on it, but for the most part, they're very good quality. So let's have a look at that base file that I talked about first. So here we go. So you can see here it's a specification again. This time I wrote it in YAML for mixing around my different types. And you can see here again what type of Swagger version is, what the path is. And you see now in this situation, the interesting part here is the definitions. And our particular definition is for visitor. And you can see, as I showed earlier, it's got 2 properties, name and ID, both type string. And name is a required property. And again, I showed you examples. So that's what's used as input when we're generating the specification, because as you can see in the specification, we reference the definition, and we'll need that to form the specification. So let's have a look at the specification now. Okay. Again, very similar to what I showed earlier, with a Swagger here at the top, and then some information. And you can see you're into definition, so it's pulled it in from the base file. And when we go down along, we can see the different APIs or paths or visitors. And you can see what I mentioned earlier about the reference here. So that's where it makes a reference up to the definition of the visitor object. And you can see here all our different APIs. Okay. So now let's see. I think it's time to maybe get this started. So I'm just going to come out of this a minute. Okay. All right. So let's start the server. Hopefully everything will start okay. Okay, there we go. So you can see it's just a simple web server that's listening on port 3000 and a local host. So I'm just going to go into my my particular VM that I'm running this on. All right. So let's see if we can make a connection. So yay, we've made a connection. Now it's just cached in here, the name for some reason in the text box, but let's put in some names. We'll go with Liam. All right. Next, let's try Mia. And finally, let's try Dan. Okay, so you can see here each time what's happening is we put in the names, and the names are being cached in the server then. Okay, so let's go and have a look at what we mentioned earlier about the documentation that's rendered. So we said that documentation be rendered at the URL, which is localhost 3000/docs. So I might have it up here earlier. Yes, I do. Okay, oh, sorry. All right, there we go. So you can see here this documentation, and this documentation comes from, first of all, a generation of our OpenAPI spec, whether you generate that inline, excuse me, or you write it as is. And then basically, by putting in the Swagger Tools API call into your particular server, it's then going to render the documentation from the specifications into /docs of your server URL. I suppose why we talk about the inline is your ability then to basically put this into CI/CD pipelines, and everything can be generated on the fly, and also to it should push your developers as well when they're making alterations to the endpoints or adding new endpoints, that they can put the comments above, and that documentation and specification, etc., are going to be rendered on the fly, which is very useful. So let's have a look at here what I talked about, the try it out capability. So we've noticed here that we've added a couple of users, Liam, Mia, and Dan. So let's see when we do a get now. So this is connected to the actual server. So it's connected into localhost 3000. So its calls should be into that. So let's see if we can get the visitors back. This is where you hope now everything will work okay. So let's see if my luck is in. Right. Let's try it out. Okay. So when we hit try it out, you can see here that there was a get request sent. And it's sent to v1 visitors because we set our base of our URL. So it's version 1 of our APIs, and it's calling on the visitors object. So let's see what the return is here. And yay, we have had success, which is good. So we see Liam, Mia, and Dan got returned, and you can see their particular UUIDs. Okay, so let's tempt fate here and let's do a post. Okay, so hit to try it out again on the post. All right, so you see in this situation, the helper comes up here, and this is from the example we put in here. One thing to notice here, I found a small little bug with that particular tool on the rendering, that it seems to always bring up the optional property as well, whereas in this situation, you don't need the ID because that's returned by the particular server itself. So let's add Henry. Okay, so you can see here that this time there was a post request sent to our URL again, version 1 visitors on localhost 3000. And you can see here the response here is a 201 and Henry's returned. And when we go back to do the get all, we should see Henry this time, hopefully. So let's do a clear there. And let's hit get all again. All right, so let's see. And excellent, Henry returns this time as well as the original people in it. Okay, so you can see here, just going below it as well, these responses below it here are giving you the description of the responses, etc., and the examples in it. So this is all part of it. So if I click down here, you can see here much better because I haven't ran the try it out. You can see here the description and then the types of responses you can get, etc., and what they mean. Okay, so how are we on time? We're 25, so we are just going to do one or two other things. So, oh yeah, just one little thing on top. If I go up to the top here. Okay, so you can see here, there's also a link at the very top, /API docs. And if you click on that, that shows you your specification, and you can see it in JSON, raw data, headers, whatever you like. So you can see that's, so an additional thing that you're providing to the user of your APIs is that you're also, no, that depends if you want to make the specification external or not, but we would suggest you do, because that means the user can always take your specification and use tools like the online generator that Swagger provides, and that is free. You can use and I'll show in a second that you can actually send a curl command, or you can go into the online generator itself and you can generate the docs. You can generate a client SDK from there. So I did this earlier because it would take too much time, and we're actually running out of time here. So I think I'm just going to wrap up, okay? But this is part of normally a longer talk I do when I was trying to condense it down today. But to just mention there that you can take that specification, use online generators or different generators to generate the SDK code, client SDK code in a language of your choice, and then the user can then basically write test code or code they want to connect to it using this code. Okay, so just to wrap up, let me just get the deck back out. So when I'm wrapping up here, I just want to say that with APIs, once you make your APIs easy to use by using good design, consistency, etc., and by making them obvious what they're to do, you're going to make your end user much more happy. It'll make it easier for them to do what they want to do, etc. Also, pulling in around the open APIs, we looked at as well that what the benefits you can get from it. First of all, how to define. It helps you defining your APIs, but also additionally the tools around it, which we showed for generating, whether you want to generate the specification using inline comments, or your documentation, or the test capability, or, as I say, generating the SDKs. They bring you value. So I would like to wish everyone the best of luck. I hope you're making really good progress in your applications, and hopefully you do very well in the call for code. So thank you. Bye.
Malaika from IBM, and I'm with Vinaya from Capgemini. Vinaya, do you want to say hi?
Hello.
Hello. And we have Mia as well looking after us here. So we're going to be talking about an amazing experience we had at the United Nations in Geneva, where we were at the office of the High Commissioner for Human Rights earlier this month. And we were working on some solutions. They were called solution starter kits, and we spent a few days working on them. And there were 4 projects. One was called Build Back Better, improving flood and drought prevention, humanitarian protection in times of disaster, and accountability and centrality of protection for affected populations. So you can see the photos of us brainstorming, and you can see Vinaya busy working on the empathy maps that we did. But what we'll do is we'll start with a small video which just gives an overview of the whole thing. So even if you don't watch the whole video, we're going to, you can listen to this.
Take into consideration the context of the event, whether it's an earthquake or a flood or any other kind of disaster, and put the community back into a position where they're more likely to succeed, to put them on a path where their ability to reduce their risk factors is better.
Our Building Back Better solution is to empower both local municipalities, small business owners, or otherwise less capable victims to have a better feedback loop going forward in the future. How do we know the next flood, the next drought is going to be better handled? Have a way to get information faster or send back information faster. How we're approaching it is going to be a collection of some cloud native type infrastructure, as well as some data set modeling information. So a lot of it is event driven, data driven, and then intelligence modeling, like Watson Studio and AI pieces of it to model that of like what kind of information has changed, even down to detecting from this image to this image, is that just damage or is that complete destroy? This kind of triggering of information so that they can find hotspots faster, dispatch help faster. The role of a lot of these open source technologies is the capability to take that approach to many different places, whether it's IBM's cloud or any of the other cloud providers. Kubernetes is largely the API now. So deploying these applications, being able to scale them out. Some of these might be getting creative with open technologies that were maybe slightly intended for something else. And these open technologies are extendable that way. You can put your hands in and get involved with it, not just use it in a single prescribed way.
So that was the last person you just saw speaking was Vincent, and Vincent was one of our team. And you also saw the amazing Adam Fish from the United Nations. He was kind of one of our advisors. It was really wonderful to have such great advisors to indicate to us what would work and what wouldn't work. The whole premise of Building Back Better is to actually, after a disaster, to actually consider making the infrastructure or whatever is destroyed better than it was, thereby giving new opportunities to people beyond what they had before the disaster. Our team was made up of Vincent from Red Hat, Enid from WPP, Gajanan from Persistent, myself from IBM, and Vinaya from Capgemini. So the challenge is to enhance the resiliency and integrate disaster risk reduction during recovery, to actually make things better than they were before. And it's been shown that this really Building Back Better makes a huge difference after a natural disaster. So this is the solution approach we came up with, and it's an artificial intelligence continuous learning with a feedback loop. So I'm going to hand over to Vinaya now to tell us a little bit more about our solution approach.
All right. So when we decided on this solution, we had 3 personas in mind. One who's a survivor who is affected. Another one who basically is the one who looks after the community or the area that is affected. It could be a mayor. And the third persona is a businessman who is part of the community and he would want to help with some additional benefits on his side. So looking at these three personas, we came up with their empathy maps, individually what their thought process would be, how they would react or feel, or like to have from back into their lives after the disaster is met. Looking at this empathy map, we basically came up with a framework where each of these personas would play a role in building their near future. Now, in such kind of disasters, what we normally see are affected are the real infrastructures like roads, buildings, their farms. There could be shortage of water or contaminated water, electricity being hampered, there is no means of communication. At the same time, so all these basic necessities which are disrupted, uh, we can target a little bit earlier to assess them and to see how we can mitigate in during or even before disaster. So the models which we considered were specifically the real infrastructure and the apps which could help us to come, assess such kind of models would be basically based on chatbots, drones, anything which could have a self portal for mayor or a business person to see whether we can provide shelter, assessment of any safe areas that we can recommend. The one of the product of this whole framework would be that a survivor from this affected areas may also would like to volunteer. He may self-proclaim as a volunteer. So collection of volunteers and grouping would be one of the best activity to respond immediately to such situations. And of course, community. Assessment of any damages, specifically property damage, how building damages, road damages would be, assessed in using this framework. I have taken a very small example out. So this is a little example of the framework that we propose to build. Property loss accessor, that's what we call. During the disaster, a user or a survivor would notify that I have a damage or a destructive property. He has to take pics of this property and upload those pictures. Using intelligence, we would, this intelligence would assess these photos. This intelligence will be capable to find out whether this particular property is completely, damaged or completely, we would say, it is destructed. So when Adam was trying to explain us this problem, he did mention one of the very small things which we caught, that there's no way, there's a very little, uh, uh, very less option where when a person says that this is a damaged property or a destructed property, and it's generally a manual evaluation of that. So we thought, why not have a system or a algo which actually assesses whether this property is a damaged property or a destructed property. Having said that, all these photos would be classified and categorized, and it will be compared with the old property photos, which would be part of a database. The percentage will be calculated from a damaged and destructed property as per the norms of United Nations, and then the loss would be calculated or the damage would be calculated, and the outcome would be that there would be some prioritization of work to restore the life back into the back to the survivor. And in case of destruction, the loss would be not only calculated, but it would be notified and prioritized as per the percentage of destruction. So this is a very small use case, but there could be many others. All right.
And so yes, as thank you, Vinay. And as Vinay said, we had three people that personas. We gave them names from Malawi, blessings, Tova and JFK after Kennedy. And we try to understand their motivations. Blessings wanted to get help fast. Tova wanted to help with the recovery, but also wanted to help, actually maybe gain some business advantage. And JFK was interested perhaps in being re-elected, wanted to target low-hanging fruit. Yeah. So those were some of the focus areas, and how we reached these conclusions is by discussing with United Nations and all our team members with the empathy maps, the person in distress, the person who wanted to have a business opportunity out of the disaster, and the government official who wanted to do well, and to continue to do well and to help the community and to be seen to be helping the community. So that's how the idea of having AI models from prior disasters, and as Vinaya said, they would produce an assessment, and then the assessment can be used to customize any apps, and then the apps could feed back into the models as the disaster unfolds. And if, for example, knowing where the damage is could adapt the model to do with buildings and roads and availability of water and so on. And again, Tova would work with a volunteering app, would hire people to help with a disaster, but then maybe these people could grow into, become hired people by Tova. And Blessings, of course, is trying to find a safe place, as is everyone initially, the mayor and the business person, and maybe get a volunteering job. So, and then having some crowdsourcing applications available to help the people, the survivors, to help others is great. And so those are the storybooks, and these are some of the technologies that we came up with for these different use cases. And Vinaya, would you like to go over some of these?
Yeah, sure. So looking at the whole framework, it kinds of the kind of models that we would be building would be purely customized model, as Susan just proposed. And these models would need constant updations from the existing assessments as well. So these will be like evolving models. Since these models are customized, what we did think was to approach such kind of frameworks with container-based deployments. Specifically, if you see one model, we could just target, let's say, property laws as one of the models, and push that, develop that, and deploy it onto cloud, of course, IBM Cloud. Having said that, the technologies that we recommend to be used would be Kubernetes. It would be completely customer-based, container-based. Since this is an evolving model, we also would like to introduce analytics, which is open scale, a database which would store images, heterogeneous data, which we could recommend as a NoSQL database. Since these are assessing models, Watson artificial intelligence would definitely come into play. We would like to use Watson for identifying any kind of images. Specifically, we would be using visual recognition, Watson assistant for chatbots. We could use speech to text and text to speech, offerings, where we also see whether we can do something with voice. Apart from that, we can also use serverless, that is Knative, function as a service here, to enable serverless technology, which can enable us to not to have dedicated applications running all the time. It could be on a need basis. There are some other possible technologies that we think of using. It could be Google Earth Engine for drones, DJI Tello drones, OpenStreetMaps for maps usage. For any kind of a dashboarding system, it could be BlinkDiff, if I'm correct, yes, BlinkDiff. And of course, it would be based on majorly IBM Cloud. So that this is where our stack would be. Everything mostly would be applicable to each of those models that we intend to build. Susan, do you want to add anything?
Yes, that was great. I'll mention the Model Asset Exchange, which is somewhere where you can go and get already trained models that you can use. Just sharing it here. The link is in the presentation. I'll be tweeting out the presentation shortly. But yeah, you can look at all these models. You can actually go in and try them, try the API. Some already have an app included with them. For example, the age estimator and the facial emotion classifier and so on. You can actually try them out on the fly and so on. So just adding that tool as well to your sort of toolkit that you can use. There are also some amazing code patterns that you can use. Code patterns are chunks of code that you can pull off the system, which give you a way of starting up with some solution. And these are some of the ones we picked up for building better, like transferring and loading CSV files into a database. Again, there's the model asset exchange models. We also pointed back to PD3R, which was a solution from last year, which has also looks at buildings and tries to figure out what state they're in. So not only looking at the code patterns, but looking at some prior solutions that can be developed further in this hackathon. Yeah. Anything else, Vinaya, you wanted to mention?
Oh no, so that's described very well. So
Okay.
Whatever pre-cooked code patterns we have, definitely we have to use.
Yeah, so these are some of them here listed, and I can just briefly quickly go to the code pattern page just so that people see them. But yeah, it's just you just Google IBM code patterns. As I say, I'll be tweeting out the presentation, but you can, these are all ready-made code patterns that you can download, and you can look for a code pattern by category, by technology. So you can look for code patterns that are to do with IoT, for example, and you just get them all coming up, and you can page through them and so on. Going back to the presentation, because I think our time is nearly up, and people are going to be joining us now, and I think they already have. So let's, these are some discussion points, regulations, if we use models, how do we, if we have this framework in place where we have models that feed into and customize apps, how are we going to encourage people to use them? This was one of our team members was on a big panel right after our time in Geneva, and this was his summary. We've included in here of what was important and the outcome of our work. We had a review with the United Nations and others, and we discussed the differences between locations. We actually included some data sets around Malawi. I think somehow we've lost that, but I'll make sure that's back in this presentation again before I tweet it out. And then finally, here's a photo of us all in Geneva. I think anything else to add, Vinaya? Are we done?
I think we are done. Yeah, we are done. We're quite done. Yeah, great.
Okay, excellent. Was there any chat questions that we need to answer? I wasn't looking at the chat. No questions. Okay. Well, thank you very much for having us. And we hope that people will use some of these starter kits in the hackathon, Call for Code 2019.
Hi everyone, my name is Rabia Mahmood, and me and my team, we were recently part of a hackathon for United Nations in Geneva, and there were various different problems, and the problem that our team were given to try to come up with a potential technical solution was to do with accountability and centrality of protection for affected populations. So what we understood of that is that in any humanitarian crisis situations or natural disasters, there's many individuals, particularly very vulnerable individuals, that don't necessarily find the appropriate means or have the appropriate voice to be able to raise any concerns that is affecting their human rights. So that was basically the problem that we have at hand, and how to help them through technology to have their voices heard. So yes, so this is so to try to empathize with the type of individuals that might find themselves in that situation. We created a persona, so that was around IBM's design thinking, to help us really relate to the individual that we're designing the app for, so we can improve, design a better software product. So we thought about various different individuals, and we felt that a persona called Amira, who is a young female, and she's roughly around 14 years of age, so she's still a child, and she's physically disabled as well, so she's an amputee, and she is basically an individual who has experienced humanitarian crisis in Syria due to certain wars that are going on there, and she feels extremely neglected, isolated, and vulnerable, as you can imagine. So we focused around her, trying to create a solution that can really help her get in touch with possibly appropriate authorities through the UN. So we, as a team, came up with an idea to try to, so we had certain assumptions when we were designing the solution. We assumed that somebody like Amira will have access to a mobile phone, and we assumed that if not all the time, at some periods in her time in this situation, in this environment, she will have access to Wi-Fi or some kind of a mobile data connection. Yes, so we assume that she has a mobile phone, and it's a smartphone. So what we understood after doing some research is around 90% of the individuals in the developing world do have access to a mobile phone, and around 80% of them do have access to a smartphone. So that's why we felt that it's creating a mobile app as a solution is a viable option. So we thought a lot about, what kind of things Amira will struggle with. So Amira would, feel quite scared possibly of raising her concerns, because there might be certain individuals in the environment that might not want her to raise those concerns, because they might, show those individuals in a bad light. So how can we actually securely and discreetly allow somebody like Amira to be able to share her concerns with the UN? So, and also we not necessarily the case that she might not be educated, but just for she might or might not be educated, and as a result we assumed that maybe she might not be able to text or write lengthy bits of messages for the UN to kind of deal with. So we assumed that she can, talk, and again, she might not be able to talk in English or, one of the languages that maybe the UN is more familiar with. So we created an app, or we hope to create an app where it could be any language. And once Amira has actually installed the app on her phone, it's a very simple app. It's two pages, where the very first page is going to automatically detect whether. Yeah, so the very first page on the mobile app is just basically going to detect the language or the environment that Amira is in, and maybe Amira can say hello, and that would automatically, in her language, and that would automatically detect what language she's using, and the app will try to record her message and then convert it to text, so speech to text, and then it would try to encrypt that text message and then send that to the backend systems, to the UN. UN will then try to decrypt that message that Amira has sent, and then sort of act appropriately on there. So the UN can actually use that message to sort of bring certain perpetrators to justice, or send some particular, appropriate help for Amira, or it can also be used again in an anonymous way back into the app on some kind of a social feedback stream that other people can read. They're also using the app and be inspired by the stories that she's sharing, and feel empowered to do the same if they're in a similar situation. So if you can see my screen, this is sort of our overall solution architecture. So on the left hand side, number one, that's basically our mobile app, which is going to send a speech to text. Sorry, it's going to be all locally happening just on the device, because at this particular stage we're assuming that maybe she doesn't necessarily have Wi-Fi or mobile data access. So the speech to text conversion is going to happen locally on the device, and once that text is basically just saved on the phone, unless she has Wi-Fi access, it's going to get stored and get sent off to the UN backend systems once she does have access. So she can, sort of feel okay with using the app and hope that when she does get Wi-Fi access, her message will be sent. And yeah, so that's basically our overall architecture. Some of the technical solutions that you can use if you're using the IBM platform is a speech to text on recognition service. There are certain neural linguistic programming services that you can use as well, language translators, various technologies like that. There are certain open source solutions as well. I'll have to remind myself what SSB stands for. It's something one of my colleagues introduced and suggested that he's used, and it's quite good. So that's, again, basically helps you encrypt the message. And yeah, so like I mentioned that, the assumptions are basically she's got a mobile phone and she's got Wi-Fi access. So yeah, so that was kind of our overall solution. I know we've kind of joined late to the Twitch sort of hackathon stream. Is anybody on the call that wants to understand a little bit more about the technical side of things, especially around maybe some of the architecture or maybe some of the technologies that we have proposed? And yeah, so that's sort of in a nutshell what we did. And if anybody has any questions, or if some of my team members are also on the call, they can maybe join in and elaborate further if they feel.
Thanks, Rabia. Hi, everyone. This is Connor here. I work for Nearform in Ireland. I'm down in the southwest of Ireland. Yeah, if anybody has any specific questions, I mean, just even on the SSB thing, that was something I suggested. It's a possibility. It's not necessarily the approach you should definitely take, but it's something that takes into account the idea that A, somebody may not be online all the time. B, they may have, a sort of very low bandwidth, and it can take advantage of. It's the type of P2P type approach that can take advantage of other users on the network to bounce messages without actually, revealing the identity or location of the original senders of the message. So it's called secure scuttlebutt. So it's something you can go and have a look. It's an interesting piece of technology, but as I said, it's just one option for how you might actually implement this, given that it addresses some of the types of scenarios you might have with someone in a difficult situation, shall we say, like post-disaster, wartime and so on. One other small thing I just wanted to mention there as well was we were cognizant, and Rabia mentioned it there very clearly, we were cognizant of smartphone penetration and so on. And there is the issue that, by taking this approach, you are excluding, you know, a certain percentage of the population. So, you know, they don't have smartphones, they can't afford smartphones, they can't afford the data plans. So one of the things I looked at after we actually did the session was KaiOS, which some of you may be familiar with. So this is low end, I won't even say smartphones or high-end feature phones, shall we say. So this is a derivation of Firefox OS and has achieved massive penetration in some of the poorer areas of the world, particularly around Africa, sub-Saharan Africa. In India, it's overtaken iOS. It's the second largest OS now after iOS, but it's the device price that's the key there. You can get these devices for less than $20 unsubsidized and below $10 subsidized. So they're selling for, I believe, as low as $7 per unit in Indonesia. And I actually, for fun, just while we're waiting for some questions, I actually got one. So that's the banana phone for any of you who's old enough to remember the Nokia 8110. This is the 8110 4G. So this is, you know, this is a KaiOS phone. It's 4G, Wi-Fi, Bluetooth, and was £27 sterling, £28 sterling. But interestingly enough, should have enough WELI, and this was the thing I was checking, it should have enough WELI to implement what we've talked about here. So for example, Google Assistant runs on this, no problem. So, you know, KaiOS is targeting the next billion people online. So, you know, one of our hopes is that this type of solution will eventually apply to effectively everyone globally. It's not, we're not trying to just go after sort of the middle classes. So.
No. Yeah. Thank you, Connor.
It is, and just to make it clear because I'm not sure for anybody on the stream, we're not doing the implementation here. So, you know, the team here has come up with the concept, come up with the ideas, you know, ideated around how this might be done, but we're not actually, you know, the individuals in this team aren't specifically involved in executing on it. So, you know, we haven't hit all the hard problems because we haven't gone to implementation yet. It really, for me, just I used to work a lot in mobile. I worked in Sweet Henry and Red Hat Mobile back in the day. You know, cross-platform, I'm generally not concerned about, particularly you know, where things are going with React Native, even things like Flutter and so on. But I do take the point, particularly as you say, around on-device speech to text. There may be limitations there, particularly if you look at some of the libraries that are available or the toolkits that are available, the number of languages is actually quite small. So if we're thinking of, you know, the extreme case, so let's say the Rohingya coming out of Myanmar and into Bangladesh, you know, there are no libraries available right now. There are no models available right now to do on-device speech to text for them. So that in itself could be, you know, an entire project. You know, what could we do, or what could one do to get the voice databases for the sort of we call it non-mainstream languages that are out there.
Mm-hmm.
Yeah, I think, you know, so Connor's exactly right. We're not actually implementing, but I think, you know, again, the solution itself, you know, we've got a few suggestions in there that doesn't necessarily mean that that's the limit of what you can try to use. I think the important thing to sort of tease out of the ideas that we had was the, you know, sort of teasing off of the Me Too movement that happened out on social media, and a few other examples like that, where you know, such as the Catholic Church's issues with young choir boys and so forth. It really takes people telling their story to sort of get others to tell their story, and for it to be really heard. And so in the context of, you know, whether it's a disaster, you know, recovery situation, a refugee situation, getting people to tell their story is the challenging part, right? Because they're afraid that if I speak out of turn, if I you know, rat on the people that are supposedly helping me, I'll get in trouble, or it'll get worse for me. And so it really does take people to be able to sort of tell their story, sometimes anonymously. Especially, I mean, I think what we saw with the Me Too movement especially was that a lot of people came out and they told their story anonymously, right? That, through a Twitter avatar. And that's when people were able to sort of loosen up a little bit and share their story. It was very difficult for them. Sometimes it's sort of almost reliving it, and but by seeing those stories told, it gets broadcast. And so I think that's, in a nutshell, that's the kind of a solution that we were hoping to be able to build, something that you could have some trust that, your identity isn't necessarily going to be exposed, but that your story can get out there.
Thank you, Connor. Yeah, no, absolutely. I think that's what on the day when we were presenting, the judging panel really resonated with that and the need for that, and they really appreciated this particular aspect of it, that it's really safe, it's very secure. Essentially, we think that this is the USP of our solution, the fact that we are creating a sort of anonymous data package, essentially, that would only be unanonymized, or certain bits of information about that data will be made available to the UN only. And between the person recording their message to information going to the UN, it's completely secure.
And to follow on that from Rabia, one of the other aspects that really became clear to us as we talked to the UN people before we were kind of ideating on our own concepts was, it is very easy for people like us to come in with a lot of technical knowledge, a lot of process knowledge, tool knowledge, and so on, but no knowledge of the domain, that we're addressing, and the challenges that those working in that domain, not just the kind of victims of catastrophes and so on, but people working in the domain have. So it's very easy to come in and say, just change everything you're doing and do it this way, and then our technology will make everything, nice and easy. So we were very cognizant of the fact that we wanted to try and fit into existing systems and existing processes. So this doesn't replace what UNHCR and the UN Human Rights Office does in terms of the legal structures they have to work under and the legal processes they have to use to evaluate reports of human rights abuses. What this becomes is a data feed into that, an extra sort of information flow for them to identify things they may not be aware of previously. So that was really a critical aspect for us, and really whatever implementation is done here, I think if it can really facilitate that by whatever means to get information from from people who are suffering human rights abuses to the people who can potentially investigate it in as we were saying, a trusted, secure way, then you've won, and everything else after that is gravy. It's fantastic, but that's the core intent.
Yeah. So I mean, I think we've discussed, we've said what I think we wanted to maybe say. If there is any time and if it's appropriate, I think maybe we can play the video that IBM has actually created for our team, for our solution. So let me see. Yeah. So let me see if I can quickly find it.
So there's of course.
Sorry. Right, let's try this.
So there's of course a range of human rights violations that we see in after a crisis, which range from violations of the right to life, people are killed or injured, but also of course violation of the right to health, violation of the right to education. You cannot go to schools or closed, the civilian infrastructures are destroyed or damaged. Violation of right to housing, right to water and sanitation, so what we call the economic and social and cultural rights, which are violated in the course of humanitarian crisis and after.
So I grew up in Pakistan, and I saw a lot of political and sectarian violence. So we thought about the most vulnerable people, sort of stuck in a humanitarian crisis, and we want to be able to give them a voice that's confidential and safe, so that you can actually use that data to be able to bring certain perpetrators to justice, as well as, sort of use the same kind of collective voice as a social facilitation, feeding back into the communities to encourage other people to speak up as well.
Our solution will basically make sure that that's encrypted and secure, non-identifiable to a broader audience, but feeds into a backend system, the UN, where they can have automated systems that scan for, issues like human rights abuses, patterns, trends, location trends, and so on. But with the nice addition of taking the anonymized data and turning that into potentially global stories that people can actually relate to and need and so on.
You're doing things for people that haven't got the skill set or the voice, or even the platforms or the environment to be able to do anything, so to be able to help them try to normalize their lives. Yes, it feels good. So yes, this is basically just a nice summary of what our team achieved or tried to achieve on the day. Sorry. Yeah, so if there are any other questions, you can ask us now, or you can always get in touch with us, and we will be happy to sort of share any more insight from the day that we did the hackathon. Can you just elaborate on the question a little bit, Maya? So apart from the UN maybe wanting to have access to the data, do you mean, or?
Yeah, so I tried to respond in the chat. Essentially, you couldn't have the information be shared by multiple backends, the United Nations, or a different a country specific department. You couldn't do that because of the encryption. Obviously, you could only have the private keys for the encrypted data held by a single party. The anonymized information could be shared for analytical purposes, but not the direct stream. You could take the solution and make it portable to different backend providers, right? So a nation state could offer the same service. I think the feeling was that the UN would be a trusted backend, and so that's much more so than any nation state might be. And so the intention here was to make it a UN specific solution. But again, you could make it portable. It just couldn't be that the backend was shared.
Yeah, we'd just like to say it was a really, really humbling, a very, very good opportunity for us to think about, creating a solution for a very, very different environment to what I'm at least used to in my daily day-to-day work. So yes, thank you very much. And I'm looking forward to whoever, whichever team develops this technology or idea, take us forward. Really, really looking forward to what they do. Thank you.
Same comment from myself, actually. Yeah, Rabia nailed it there. It was an incredible experience for us all to be involved in it. And we're more than happy, I'm more than happy to talk to anybody about any aspect of the technology things that we suggested. Whilst I think, Chris would be the expert on the IBM cloud services piece rather than me, anything around Node or, even the SSP thing, we have relationships with some of the people involved in these projects just on a personal basis. So, if people need a hand or a dig out or anything like that, or just advice, we're always there to help.
Yep. Yep, great job, Rabia and Connor. Thanks a lot.
Thank you. Thank you, Maya. I'll wrap up here then. Thank you very much.
Hey everybody, thank you for participating in our virtual hackathon, Call for Code 2019. I just wanted to wrap up here and go over just a few more things, keep things fresh in your mind. I know you probably have seen a couple of these slides before, but I'll go through them quickly here and just kind of recap some of what you've seen before and go over some final resources and things to keep in mind. So just to recap, my name is Derek TA. I'm a developer advocate at IBM. For Call for Code, this is our second year running this competition, which is focused on generating technology solutions to the world's greatest challenges, right? So, as most of you probably know, perhaps from personal experience, natural disasters are a growing threat to communities around the world. But fortunately, with what we've been focusing on, there's a community of over 23 million software developers that can use their skills to help prevent, mitigate, or recover from natural disasters. If you think about how developers have changed the world already, they've created software that help you connect with friends, find answers to things pretty much instantly. You probably use your phone for directions, right? So that was developed by software engineers. Ordered a coffee maybe, from your phone. So all these things are designed by software engineers to help people, right? So it's great to try to have them focus on helping people more as it relates to natural disasters. Just some statistics that you can see on the screen. Almost 800,000 plus worldwide deaths were attributed to earthquakes since 2010. So why not try to do something about that? Why not try to help, right? And this is the whole focus of Call for Code, and this is why we do it. Within that scope, there's several potential problem areas to learn about and explore when we talk about committing to the cause and pushing for change. So some of the problem areas we like to focus on are reducing vulnerability by managing disaster risk over the long run, forecast impending threats to improve preparation in the short term, responding to medical needs during the disaster, and improving the resiliency of communities to restore health services after. Some other solutions you can look at here, there's a few suggested solution areas you might want to use as starting points for your ideas. Maybe the idea about alerting pharmacies for increased stock for things that people might need after a disaster, or analytics to predict the impacts of disasters, things like that. There's a lot that you can do here with this whole Call for Code challenge, and I hope that you've gotten some good ideas throughout your time at the virtual hackathon. But here's even some more ideas to kind of ponder. For Call for Code 2018, we had an amazing participation from all around the world, and we're seeing the same enthusiasm again this year for Call for Code. Last year's winner was Project Owl. They had an amazing idea, which I'll talk about here briefly. But for Call for Code 2018, we had over 156 nations that contributed, with over 100,000 developers that also participated. 40 celebrity supporters, which were great that they shared our message of wanting to help with natural disasters. And for the winning team, Project Owl, they had a great prize for all this. So they had a Call for Code award. They had a really large cash prize, venture capital investment introduction, open source project support from the Linux Foundation, and on the ground deployment, which we'll talk about here now. What they did earlier this year, they did their deployment in Puerto Rico. They used their idea, which was basically to create a mesh network that would allow people to reach first responders via their duck network. It was an IoT network that was accessible via mobile phones, and then it would send their data to their own software they created that ran on IBM Cloud, and it was an awesome solution. So I was actually fortunate enough to be able to test that with them in Puerto Rico earlier this year, and it was pretty amazing to see just how their idea came to life and how it just all worked. So this is something that would happen if you were to win the Call for Code challenge this year. You have the opportunity to have IBM support your deployment and test your solution via code and response. And these are just a couple quick photos from Project Owl and the IBM Corporate Service Corps that helped do this implementation in March. It was a great opportunity. So just a few photos there. There was also a documentary that was covered as well about this whole thing. They were featured in several articles, which if you want to know more about Project Owl, you can find them at project-owl.com. Beyond this initial test and deployment that we did in Puerto Rico, we've also worked with Project Owl on additional deployments in Houston, and we're connecting them with additional deployment partners for them to continue to test their solution. Beyond Project Owl, we had submissions from around the world, and we've been working with some of them to help deploy their applications and gain support from the Linux Foundation. So these are the additional 2018 finalists that included Lolly, PD3R, Iris, and UAN. Again, lots of very, very excellent solutions from around the world. So if you'd like to find out more about them, please take a look. To give participants a starting point, we've mapped IBM technology to the identified needs in 6 different areas. So I talked about this a little bit yesterday when we went over the Call for Code, developer.ibm.com/call for code website. They were data science, AI, blockchain, traffic and weather, Internet of Things, and machine learning. So these act as a bridge between the developer and the NGO frameworks, but they're not a rigid structure for submissions. But these code patterns that we've identified fall into these 6 areas that you can explore, which of course you're not limited to them, but you can use them to inspire whatever you build. We also showed the 6 industry areas as well: automotive, energy and utilities, fintech, healthcare, retail, and telecommunications. So if you're interested in looking at something from an industry perspective instead of just a technology perspective, that's a resource for you as well. And we have the 6 major disaster areas as well: earthquakes and tsunamis, hurricanes and typhoons, wildfires, volcanoes, floods and storm surges, and extreme weather. So whatever perspective you want to look at for natural disasters, there's something for you as well, whether it's by the technology, by the industry, or by the disaster itself. You also have materials around community health and well-being, which is our focus this year for 2019, as well as natural disasters. So you can take a look at that also on developer.ibm.com/call-for-code. Lots of resources there as well. There's 4 issue-specific starter kits as well. It's our newest set of resources available. We call them our starters. They're proposed solutions for a scenario in each of the 4 problem areas that were identified by the United Nations Human Rights Office and the United Nations Disaster Risk Reduction Organization. They're meant to encourage solutions to real-world problems, and they can be used as a starting point for solutions you create for Call for Code. And each one of these starter kits includes an architecture diagram, a list of recommended technologies, and a use case that describes the solution from the point of view of someone affected by that disaster. They'll be expanded with additional starter material, including use cases, additional use cases as well. So if you are looking for something pretty comprehensive with a particular description and detail, and to kind of give a full picture of disasters, that also could be a great starting point for you as well. As far as judging, there's 4 criteria. They're judged for quality on based on how complete they are, how effectively that they solve a particular problem, how they scale, and if they bring a completely unique approach to the problem. So those are the most 4 important things to focus on: completeness and transferability, effectiveness and efficiency, design and usability, creativity and innovation. So as you're designing your Call for Code solutions, keep these in mind and make sure that your solutions can speak directly to these areas. That'll give you your absolute best chance at winning this competition. There are a few official rules. They're in the participation agreement that you accept upon registration. One of them being build a new solution for this challenge. So it's what we call the fresh code rule. So you have to have code built between March 29th and July 29th. Can be open source or previous components, as long as they were available to all participants as of March 29th. As far as the team, it's teams of up to 5 people, at least 18 years old, and you cannot be a part of multiple teams. And one of the other key rules is that you have to use the IBM Cloud or cloud services. You can see all of the options that you have for the cloud if you go to that link there, cloud.ibm.com/catalog. You can also use other open source libraries, data sets, external services as well, but you have to use IBM Cloud Services. So take a look through there. There's a lot of really, really good technology there to help you with your solutions. I know we've talked about a lot of them on the live stream, but any of the 6 focus areas that we talked about are all available on IBM Cloud. If you want to do things like speech to text, text to speech, anything like that will be available for you to use on the IBM Cloud Service Catalog. So please take a look at that. In short, you can compete as an individual or a group of up to 5 people, but you have to make sure at submission time, it's only one team and you submit one application. So remember that when it comes to competing as a team. 5 people, up to 5 people, and at submission time, only one team, one application. For 2019 submissions, the submission form is available now. You can find that on callforcode.org/submit. Make sure you also understand the participation agreement, which is there as well. That's right underneath, if you're looking at the screen. The blue button is to submit. Right up below it is the participation agreement as well. You're also welcome to update things later. So if you think your application is pretty well ready, good to go, you can submit it and you can update it up until July 29th. So feel free to do that. Just make sure that everything's in there. Make sure it includes your submission name or the name for your solution or your team, a short description, about 10 words or less, and then a long description that describes your solution in more detail, what you built, what problem you're solving, why it matters, how this is different. You have 500 words or less to do that. just to go through a few tips here, understanding real world problems being the first of them. We're looking for something that has a lasting impact and brings some technology that solves real problems and creates sustainable solutions. So make sure you thoroughly understand the problems that we want to solve and the problems that we can help solve for the world as it relates to natural disasters, and how technology can help you solve that particular problem. Couple tips here, or a couple resources here under this tip would be, you can check out the UNDDR Sendai framework. There's a link there for that as well. There's a lot of tech talks with subject matter experts on things that talk about natural disasters and some of the problem areas behind that. And you can look into additional research in the field, such as digital humanitarians. Very interesting topic, so I would encourage you guys to take a look at that as well. Another tip, and I think this one's very important, don't reinvent the wheel, right? You'll come up with some ideas, of course, but certain things already exist, like tools, data sets, APIs, things of that. So instead of designing things like that from scratch, you can use existing things that are already built for that to kind of help you save some time and build your solution around something that already exists. So it would be important to look into things that exist that can already help you with it, instead of spending a lot of time trying to design something that may already be there. You could take a look at, for example, if you're looking for, here listed, the OASIS Emergency Data Exchange language format. If you're looking for some resources on things to do in a natural disaster, or response, those are some things. OASIS is something you can look at as well, just being one of the many tools out there that already exist. Tip number 3, also very important, document your code and your source code repository. So like we talked about, your submission you need to have in by July 29th. You want to make sure that your submission has really, really good documentation, a strong README file that explains not only what your solution is, how it works. This is where you want to have the technical information on how to stand up your solution, how to set up things, how things need to be configured, how it should run, any input or output that should come out of it. That's something very important, because when it comes time to be judged, we want to make sure that we can understand your solution and have it fully running the way that it was working for you and the way that it should have been set up. So please make sure that you have a very strong README file. You can always take a look at README best practices and see the best ways to set up a README and what content should be in there as well. Also feel free to create a video link that would explain how to set up your solution. That can be included in your README as well. Tip number 4, invest time to create a powerful video. So as far as it goes when it comes to judging, the challenge is going to be judged by a panel, and it includes people with deep expertise in technology and understanding of natural disaster and impacts on societies. So, it's very important to create a video that is compelling and allows people to really get a sense of what your solution does. You could take a look at some of the ones that were done last year and see what they did, but it would be very good to, for format, you have 45 seconds-ish on what exactly you're trying to solve and how have you solved it. Maybe a minute and a half on the demo of the submission itself, full flow of your user interface, and 45 seconds or so on the results and the next steps. So all in all, you're looking at about a 3-minute video. Definitely be my recommendation to create something powerful that is eye-catching and attention-grabbing to the people that'll be judging this. Last year we had judges that included Bill Clinton, Kate Gilmore. We had a lot of people that were very, very influential in this, and we want to make sure that excuse me, that your submission draws the attention of the people that are doing this Last tip for you, double check the permissions on everything that you send in. So make sure that the repo that you have is publicly available after the July 29th deadline at latest. Make sure that when you publish it that you're using the most popular license today, which is Apache license version 2. If you choose to not make your repo public, ensure that you add call for code judges as an outside collaborator. Very important, because when we go to do the judging, if we can't see repo, if we can't access it, if we can't look at it, we're not going to be able to judge it. So it's very important that we're able to have access to where all of your code exists. If you have a private video, same thing as well. Include the password with your video link. Just important that we can get to everything that you're submitting so that we can judge it appropriately. So again, you can always get started if you haven't yet, or if you want more resources, developer.ibm.com/call-for-code. Join the community if you haven't already. Build with code patterns and resources. We talked about that numerous times on all the resource areas and tech resources that we have for you. Engage experts and find teammates, and submit your solution. So these are the 4 steps that would start from beginning to end with your call for code solution. I really hope that this has been helpful to you, this presentation, as well as the entire virtual hackathon that we just have put on. Again, if there's any further questions on anything that we've talked about, feel free to reach out and we'll make sure to get you answers to questions that you have. Thank you again for participating in the Call for Code 2019 virtual hackathon, and we'll see you later.